was introduced as being from the University of Washington. Since I submitted the abstract, I've actually left the University of Washington, and that was a part-time job. The other part of my job is to work with the Washington Farm Forestry Association. It's a small forest landowner association in Washington State. And so this particular presentation is based on some work that I've been doing with them. And interestingly enough, it's kind of a follow-up of my master's work that I did 15 years ago, a long time ago, that looked at these Eastern Washington systems and the regulatory impacts on them. So this is one of those things where, you know, you think you leave your past behind and it comes back for you to take another run at it. The title is Riparian Management Alternatives for Forests Under Fire, an Alternative Approach to No-Touch Buffers. You'll see a co-author there, Kevin Cedar. He works for a company in a consulting firm in Washington, Kramer Fish Sciences. Kevin and I worked together at the Rural Technology Initiative in the early 2000s. He's what I call my Uber geek. The guy is a silviculturalist who's phenomenally good at managing big data. So I was really, really happy when he became the person that helped take on and shape this particular look at what we could maybe do in riparian zones in Eastern Washington. I put the abstract in because I knew that this would be used in the future. I'm not going to read that. I'm going to start with the story. Now, early on, I want to say that when we're talking about forests and wildfires in the western U.S. in particular, but in the U.S. overall, and when you mix that wildfire conversation with the conversations of climate change, you hear that science is telling us we have a problem. As early as 2004, Don McKenzie, who's PNW Fire Lab, had done this work on climate change wildfire, and basically for the western states was predicting on average a doubling of fire area burned in wildfire by mid-century, so by 2050. That was Don's conclusion. Don was actually on my graduate committee, so I worked with him on a number of different things. And then in 2008 or so, we worked for the Washington Climate Change Impacts Assessment Group. That was a big group to look at what are the impacts of climate change. Jeremy Littell did all the fire analysis. I did a bunch of bug work in that second one, and then McKenzie and a few other folks, which basically looked at the impacts of climate change on these predictors, most of which occur in Eastern Washington as opposed to across the state. So science is telling us we have a problem with increasing fire in these systems. And I would say national fire statistics are also telling us we have this same problem, if you will. A doubling of the number of acres burned when you start counting from 2000 forward relative to 99 looking backwards. This is from National Interagency Fire Center statistics. It's a statistical doubling. So to me, what's interesting about that is that McKenzie in 2004 said, well, we're going to get this doubling by mid-century, and we beat that prediction by about 30 years. So we're already seeing that doubling of acres burned. There was a talk earlier this morning that maybe that's not enough to bring us back to some historic condition, but certainly it's something that's affecting the wildlands, the forests, and it's affecting people's livelihoods, not unlike the conversation we just had about, okay, you have people in these systems, how does that affect them? And I'll say that so are the news media. The news media go on and on about how bad it is, how bad the fire condition is, especially when the winds blow the smoke into western Washington. We heard about that all summer, about how bad the smoke was. It wasn't actually coming from eastern Washington, it was coming from British Columbia and California mostly. In 2015, we had our worst fire year ever in Washington State, about over 1 million acres burned. That's the first year that we exceeded 10 million acres nationwide. It was a stinker of a year. It wasn't quite as bad as the second one. That one is actually in Alberta, Canada. They burned 1 million acres in a couple weeks in May. It rarely ever gets above 60 degrees in May in that particular part of Alberta. Again, these very extreme events that are fundamentally altering the conversation about what do we do when it comes to wildfire. That particular one it hit pretty close to home. I actually had relatives in there. They evacuated 88,000 people out of a community in a matter of a few hours. It's really stunning. Now, management agencies are also talking to us about fire. They're talking to us about fire and insects and disease and forest health. This is a picture of the 20-year forest health strategic plan that the Department of Natural Resources, I think they did the big rollout about a year ago, and they're going gangbusters on trying to implement things that will reduce fire risk, address these forest health concerns that are driven by fire. So we certainly have all of these entities sort of lining up on we have a problem, we know we have a problem, we're going to take some bites out of it. The one place where we're not maybe moving that quickly is that the regulatory programs are relatively insensitive to these kinds of changes and these kinds of challenges. In Washington State, we have a Forest Practices Act. Like Oregon, Washington, California, the western states have Forest Practices Acts. Much of the rest of the country has best management practices. So we have a different set of rules. Our law came into effect based on something called the Forest and Fish Report in 1999. So it was based on negotiation using the science in that era, pre-1999, and there's a lot of history around how it was developed and why it was developed in a particular way. It covers all private and state-owned forest land in Washington State, not federal, and it has from that agreement a whole suite of rules were developed based on the forest type, the stream width, whether or not you're in western or eastern Washington. It's a really, really complex set of rules and regulations. Went from a thin rule book to a very thick rule book to try to address these concerns. And we had, of course, this goals here that were attempted to be achieved by developing through this regulatory program. Supporting harvestable levels of salmon, because we have that requirement under some laws that were passed to support tribal levels of harvested salmon. Support long-term viability of other species, so deal with the Endangered Species Act. Deal with water quality, and that's really important there because we have a state. Our state actually manages water quality standards set by the federal government, so we have some authority there. And then support an economically viable timber industry. Those don't always see eye to eye, so we have this sort of negotiation process built into it, but you can imagine how those competing goals sort of set up a tension within a regulatory program and make it maybe not all that flexible to adapt and to change. To give people who are not familiar with Washington a sense of what that looks like, this is the map of the state, and all the color is forest, except for whatever reason, Luke happened to throw in this. These are Department of Defense lands, these bright yellow. Everything that's in green is federal. Everything that's in dark brown is small private. Light brown or that tan color is large private and industrial. You have these nice sort of purple areas, which are sort of state and county, but not DNR. And then you have this really nice, I guess it's aqua color is DNR. So you can see that these regulations, the forest practices regulations, cover everything but the green. The area that we're going to focus on, the area that has this elevated fire risk, is actually eastern Washington, and that's not I freehand drew that. It's not perfect. But essentially, east of the Cascade Mountains, you have this dry much drier environment, similar to what we're talking about in the Himalayas, where it's a fire-dependent system. From low elevation to high elevation, you have different fire regimes, but by and large, it's a fire-dependent system. On the west side, it's a lot wetter, a lot more productive, and certainly when you have a fire there, you have some pretty extreme conditions. So we're going to focus on eastern Washington for the remainder of this talk. So just a short synopsis. The Eastern Washington's riparian regulations. The particular regulations, I think it's really important to recognize that when people develop these regulations, they inherently recognize disturbance as a part of these systems. The intent was, let's figure out how to manage disturbance as part of our riparian strategy. That's the goal. They had it's a really detailed, prescriptive kind of regulation. It applies to all fish and non-fish bearing streams, and you have essentially, if here's the stream, you have what's called a core zone you don't cut in. You have a potentially manageable zone called the inner zone, and then you have an outer zone that you can manage. The widths of those vary depending on the size of the stream, whether or not it has fish, how far up the mountain it is, and some forest type variables. It's really complicated to figure out if you can work in those systems. You have to do 100% cruise, you have to go back, you have to mark them, there's actually 2 floors. It's a really detailed, complicated process. So what happens in many cases is that you do nothing. Particularly for small forest landowners, what we're finding is put a line on the outer side of all of that stuff and say, just leave it alone. It's too complicated. I can't do anything. I don't want to do anything. And you end up with this thing that I call that's a really juicy riparian zone. The problem is when you run a fire through it, it ends up looking something like this. And this is an example from the Stickpin fire, which was part of that 2015 horrible, horrible fire year. So clearly when you put those two together, and when you think about, 20 years, we've doubled the fire rate, we have all these things going on, the idea is that you have to really start thinking, do we need to shift our paradigm? As part of the program, there's these functions. And I've listed 5 here that we are really intent on trying to provide within those riparian zones. So obviously you want to have temperature control. Our fish like cold streams, so you're going to use shade as a proxy for stream temperature. You want big wood, minimize erosion, maintain your hydrology, your intent, and your chemical inputs. For the most part, we kind of focus on those first 2. If you handle those, then the assumption is maybe those other ones will fall in line. And so the work that the analysis that we did basically focused on shade and large wood as sort of proxies for all functions. I bring those up because when you look at your juicy riparian zone, clearly all of those are met. You can check the box. Yeah, we did a good job. When they burn, we know that we actually get a lot more dead wood. So that function is met. We don't know really, we think if shade is correlated with temperature, then this is not really meeting your shade target. We don't know what's going to happen with sediment delivery, hydrology, chemical input. Those are questionable. So the point being about this is, remember, the intent of the regulation was to account for this disturbance regime that we knew existed. I mean, we didn't develop these things with our head under a rock. The idea was to account for them. So why are they looking like this instead of what we had envisioned? So to answer that question, as part of this program, we do something called adaptive management program. It's funded, where people go out and they develop the research questions to answer to provide the answers, provide the science that wasn't there 20 years ago when it was started. Two major studies have been completed in that last 20 years. There's that are relevant here. One's the Eastern Washington Type F Riparian Assessment Project, ERAP, and then a bull trout overlay. Both of those collected data that looked at the stand conditions of, basically if here's your stream, perpendicular to the stream. What we did is, in collecting that data, it provided us information that we could use to then say why are things not working the way that they are, and how might we alter that. That's the way that I looked at using that data. So we were able to access that data that had been collected as part of this research program. So it's it was collected for other purposes. So in that way, it wasn't specifically saying we're going to sort of capture a random sample of what's happening there, but it was certainly captured a representative sample of the riparian conditions in eastern Washington that we could then use to run an assessment on. We took that data, and remember I have Kevin there to do the big data analysis, and we were able to use that transect data to develop spatial stands, if you will, in the core, the inner and the outer zone of these riparian zones, and put that into forest vegetation simulators so we can model the impacts. We modeled, what the stands looked like, and then to assess shade and dead wood, we used some models developed by Tepley, mostly Mark Tepley, who also works with Kramer Fish Science. So we have this system of now we can model what might happen. And then what we did is we ran fire through this. We simulated impacts of fire through these riparian zones to see what are the impacts, both under current regulation and under a number of different alternatives that we thought, based on our silviculture, might give us a better outcome. So when we ran the fire through, I think it was important to say it wasn't a super hot, aggressive fire. It was like normal wildfire conditions that are built into the fire and fuel effects model of FES to get an understanding what mortality might look like when you burn some of these forest stands. This, I think, was really a shocker to both Kevin and I. So all of those stands that we had, we populated these things, we ran the fires through them, and we looked at it and said, wow, current stands, 67% of them, if you run a fire through them today, they're toast. 100% mortality. Another just about 12%, 75% and up mortality. And frankly, most of those are at 99%. You get one stick per acre alive. So really, you're looking at just about 88% of your 75% of your stands, or 79% of your stands, you're losing more than 75% of the volume when you run a fire through it. You have a few stands that are kind of where we thought they would be, where we envisioned with that the kind of inventories we envisioned would be supportive of riparian function and accommodate disturbance. And we're like, well, how do we get these stands to here? Is that even possible? It turns out in some instances it is, and in some instances it's not. Our forests look substantially different than they did I would say pre-settlement, pre-fire suppression, pre-harvesting. A lot of fire-intolerant species, a lot of ladder fuels, and very, very high densities. They look substantially different than what we imagined we could accomplish under the rules and regulations that were developed in 1999. So I think the take-home message is that if we treating these riparian zones as if they exist outside this realm of fire excludes the opportunity to do something that would create fire-safe conditions for fish and improve water quality. I know that in talking with the folks working on forest health, remember that program's just starting, they're up and running, they're dealing with uplands because that's a lot easier than trying to address a regulatory program, and they frankly can't at this point in time because it would be against the regulations. So my question was, looking at the data, getting this information, and just kind of going, oh, I thought it would be easier. I thought we'd have something to work with. We really, in a lot of cases, have nothing to work with. So what can we do? And I used this picture. This picture actually was given to me by the guy who wrote Fire History in the Pacific Northwest, Jim Agee, back in the 2000s. And I was like, that's quite a picture. So the riparian zone burned and the upland didn't, which is sort of the antithesis of what you think. Riparian zones are wetter, there's higher humidity, it shouldn't burn. And he said, well, what had happened is the uplands had burned in prior years, and so when the fire started, there was a lot of dead wood in the riparian zone, and it just cooked up the riparian zone, hit the upland zone, and died. No fuel, it died. The question is, can we structure anything to make that not happen? What do we do? What can we do? So Kevin and I put our heads together, and we came up with a number of different alternatives. And I'm going to show you a couple of these charts, so I'm going to explain it once. So we threw alternatives at this. We tried a bunch of different things. But the way to read this chart really, and I'm going to leave this for a second, is these three columns are 100-foot buffer, forest and fish, all available shade. Just think of those as basically, they don't really touch the forest. These ones is a 50-foot buffer and a 30-foot buffer and take everything else. And then these are 75-foot buffers where you do various levels of removal from below, either 10%, 20%, or 30% basal area, and then you either focus on several species that can handle fire or you don't, and then that was a 50-foot buffer. Now, this is before fire, so that's year 0. We did all of those treatments, and this is 0 to 100% effective shade. No surprises. If you leave it alone, you get a lot more shade, as you would expect. Oh, and the only other thing is, this is a large stream and that's a small stream. You put the same inventory over a large and a small, and it makes sense. If you're further from the bank, if you have a wider stream, you have less shade hitting it. And as you increase the intensity of your management, the amount of shade goes down. It's not a surprise. That's what we would expect. Not as far down as you would anticipate. And then this is everything after the fire. So then you put it in, you run a fire through it, and then you grow it out for 30 years. He did not simulate regeneration, so it might be a little bit of change, but in 30 years you're not going to get much shade anyway. The thing that struck me about this is I was thinking, oh, if we do 30% basal area removal from below, we're going to see a huge impact. They saw an improvement, but it wasn't. Thank you. It wasn't wonderful. These are median values. It was not wonderful. And so I went back and said, okay, a median means half of them are above and half of them are below. I mean, this down here where you're down at like 10% is a median value for those stands. It's consistent with, 75% of them are dead. So I went back as a good scientist and said, what are the distributions looking like? And this is the same structure, and these are the distributions. So that's before fire, and this is after fire. And I think I have one more circle in here. I do. So those few stands up there where we had some pretty resilient forests before treatment. It's like, okay, that's what I want my stands to look like. We don't need to mess with those stands. Those stands are fine on their own, and you probably couldn't enter them under the current regulatory environment anyway. The question was, is there something here that we could do to improve the outcomes? What are there stands here that we can do something to improve the outcomes, and what might that something be? So we went back and looked at the data, and instead of looking at medians, I just wanted to look at the things that did well and figure out what we could use to develop some prescriptions for moving forward. number of ways to think about this. So this is still a work in progress, but the way to think about it is we had, over on the far right, we had a number of inventory samples. And then of those, we had, I'm using this cutoff of basal area of 60 square feet per acre. That's actually, in this system, the core zone is a no-cut zone, but the middle zone, the management zone, is 60 square feet of basal area, 50 trees if you're in low elevation. I wanted to use that as a cutoff to see where I could, how I could move forward from there to try to parse some results out. So, of the stands, about 85% of them actually meet that criteria of 60 square feet of basal area in the core zone. When you run a fire through it, obviously you're losing, about 60% of your stands under forest and fish are 100% dead. Some of them do okay after the fire. And then obviously if you remove ladder fuels, the more you move, the better it looks. That's the way to read that particular chart. Now, I'd asked Kevin to run the shade values, and he wasn't able to deal with that. He's dealing with something else at the moment. But essentially, we can anticipate that if we were to do these kinds of treatments, we would end up with better outcomes after the fire than if we did follow the current regulatory environment. That's the way to read that graph. And then I threw in another, because there was a number of stands where you couldn't meet the 60, but you could meet like 50 or 40. So you were halfway there. And the best thing about that was you were leaving some big fire-resistant trees, the few that were there, that would move into developing those riparian functions that we're looking for. Which silviculture prescriptions worked? This is on a hillside. I didn't have any riparian zones where we'd actually done this, so sorry, but it's a good picture. Basically, the more you remove, usually the better, just because the densities were so high. There were so many trees, and it allowed you to remove more of the ladder fuels, the fuels that move the fire from the ground to the crown. You wanted to create that canopy discontinuity so you don't get a running crown fire. Larger diameter obviously is better, and the fire-resistant species were better because they had a better chance of surviving. And obviously, if you don't have crown all the way to the ground, you're going to end up with a better fire outcome. And I think the take-home message is fire is inevitable, but we don't have to live with those particular impacts. Its impacts are not inevitable. We did get fireweed coming back the next year, and I think I found maybe 10 trees per acre in my mini silviculture survey. And I would like to say that a little fire is better than a lot. And I always like to end with this picture of one of the small forest landowners doing what he does best, which is jackpot burning. So that's where we are. Essentially in the process of developing this and putting together a proposal that we would bring before this committee and look at, are we going to develop some sort of a specialized template for small forest landowners that they could use to try to improve the health of their riparian zones? Is it going to be a rule change? It's going to be some really interesting conversations, I would say, in the next 2 to 5 years. Probably take that long to change rules. But to really look at how do we provide the kinds of riparian functions at what level moving forward, given the stresses that we're seeing in these systems in terms of the fire and fire impacts. That's it. Culture prescription.